Most people think a saw is just a piece of steel with teeth. This one goes through 800 degrees of heat, a bath of rapeseed oil, and 30 separate processes by hand. And it starts with something most people have never heard of. Saw. The saw is a tool used to cut wood by pulling. Various types exist depending on the nature of the wood and the purpose of the work. There are rip saws for cutting wood along the grain, and crosscut saws for cutting across the grain, back saws for precision work, and others, each serving a different role depending on the material and method of cutting. A saw consists of the blade and the handle. The names of each part are as shown. The teeth of a saw can be divided into rip teeth, which cut along the wood grain, and crosscut teeth, which cut across the grain. Rip teeth are structured to scrape away wood like a chisel. A tooth consists of an upper edge and a lower edge. The angle between them is called the cutting edge angle. And the angle between the line of the tooth tip and the lower edge is called the rake angle. Crosscut teeth are shaped to cut through wood fibers efficiently. Crosscut teeth have upper and lower edges, plus alternating side edges. The rake angle is generally set at 90 degrees, and the cutting edge angle is approximately 45 to 60 degrees. All types of teeth are given a set. The set creates a curve wider than the saw blade itself, which reduces friction against the wood. This is what allows the saw to cut with a light pulling motion. Now let us look at the process of making a saw. First, cutting the raw material. The steel plate is cut to the dimensions of the saw being made. The steel thickness is 1.8 millimeters. It is cut with minimal waste. Forging. The cut steel is heated, thinned out, and shaped. Pine charcoal, which produces high temperatures, is used as fuel. To retain heat, 2 to several pieces are forged at the same time. With only one piece, the temperature drops too quickly and efficiency suffers. The process of heating and hammering is repeated 3 times. Annealing involves heating the steel once in the furnace and then waiting for it to cool. By hammering the cooled steel, surface irregularities and twists are flattened out, and the steel is compacted by the hammering. It is scribed to the required dimensions and cut. The Tang welding process. The tang is heated and shaped. After heating, a short joining piece is attached and welded to the tang. The joint portion is heated and hammered to forge weld it firmly, and the shape is refined. The tang section is formed using a cutting machine. It is heated again for further forging, a process called forming the machi. Each tooth of the saw is knocked down individually with a steel tool. This is called tooth blanking. Both rip teeth and cross-cut teeth are tooth blanked in turn. Before hardening, the blade is clamped in a tool called a nokobosami, and the first tooth setting, called nama metate or rough tooth sharpening, is performed. Mei-fusei, using clay to flatten all the teeth so the blade thickness becomes uniform. Rough polishing removes surface impurities and flattens the blade. Now it is time for hardening. The saw is heated to 800 degrees Celsius and rapidly cooled in oil. Rapeseed oil is used. Pressure is applied to prevent warping caused by the temperature difference. The saw is tempered to the appropriate hardness for each type. Additionally, the tang area, which requires a degree of flexibility, is separately tempered. The degree of tempering is judged by the color difference. Edge straightening, the process of flattening the saw, which has warped slightly during hardening. Since the blade has now been hardened, it must be hammered carefully to avoid breaking it. A tool called a sen is used to scrape and flatten the surface of the saw further. The sen work is a critical process that determines the balance of the saw. This tool is called a sen meshi, a finishing version of the sen. Uchi awase is the process of removing any remaining warps. The shape of the clay used here is more pointed than in the earlier flattening stage, requiring even greater precision. Buff polishing to smooth the surface of the saw. It is further polished with final sanding. Edge rounding, smoothing and rounding the corners. The color raising process, which gives the Tang the distinctive color unique to Miki saws. The blue-fired Tang is the mark of a genuine Miki saw. The blade is wiped with oil to prevent rust. The teeth are struck alternately to create the set. Striking every other tooth on the edge of the anvil requires a delicate sense of touch in the fingertips. Final tooth sharpening is carried out with a fine-toothed file. Just as with the set striking, every other tooth is filed in turn. Different files are used according to the shape of the saw teeth. The final process, the last straightening. The clay marks from the straightening process left on the saw are unique to Miki craftsmanship. Different clays are used as needed, and once the warps are removed, the handle is attached and the saw is complete. The number of processes it has passed through is approximately 30. Blades forged in 10,000 forms. This is how the saw is forged and completed. The metalwork of Miki, refined over a long history. Within that tradition, the blacksmiths have built and cultivated their own unique techniques. Tools that pursue the essential, and a culture that must be preserved. The Miki tool blacksmiths wield their hammers again today.